Hi guys, Reg here. So I've got myself here a battery charger. You can charge 6-volt batteries, 12-volt batteries with this battery charger. So what happened is one morning I woke up and my car battery was dead. I think mainly because we're getting into winter, so it was a cold night. When I woke up in the morning, my car battery was dead. So I jump started it, went to work, came back. When I came back, disconnected from the vehicle, put it on this battery charger, left it overnight. When I woke up in the morning, the battery charger, it stopped working. So I'm gonna try and fix it with you guys. Sorry, I've already disassembled. I didn't show the process of disassembling, but as we can see here, we've got ourselves a transformer and a couple of components here on the circuit board. So we're gonna test each components together and try and find out what the problem is. So first we're gonna start by testing the transformer. After the transformer, we can disassemble the capacitors, diodes, and the resistors from we can desolder from the circuit board, test them with a multimeter. So stay tuned. So you're gonna have to forgive me guys, it's quite difficult if using one hand is on the camera and the other hand is on the multimeter leads. So as you can see, I've connected my multimeter to one wire of the primary coil, and I'm going to connect the other wire to the multimeter positive lead. As you can see, we do not have a beep. So on our diagram, one multimeter lead is on here and the other one is on here. So this is where we have a problem. We have an open between this wire and this wire on the primary coil. So now we're gonna test 1, 2, and 3 if there's continuity amongst the three. Here's our multimeter lead placed on one of the three wires. As you can see, we have continuity. We also have continuity here. If we move our multimeter lead to the middle wire of the secondary coil, we have a beep, which means it is continuous. We also have a beep. So our secondary winding is fully functional. Let's disassemble the transformer and see if we can manage to fix it. So as you can see, I've already disassembled these E and I lamination sheets. I didn't want to take you through the process because it's very easy. Once you take off the first sheet, then the other ones are easy to take off. Here's how you take off the I and the E. So I've managed to disassemble the transformer. Here's our secondary winding. So the faulty part is the primary winding. Now we're gonna take off the insulation so that we can gain access to the windings. So I unwound a little bit of the primary coil, checked for continuity between our primary circuit. We still have no continuity, but only up to this component here. But after the component, we've got continuity. So the open is in this component. This is called a thermal fuse. So this fuse is open. As you can see from here, from the other leg of the thermal fuse, we've got continuity. We've got continuity from the other leg of the thermal fuse. Is a closer to Elon primary winding. No continuity from this side, but we've got continuity on the other leg. So now I'm going to replace this thermal fuse, and then we'll take it from there. So this is our replacement fuse. As you can see, we've got nice continuity. It's nice and continuous. Same rating fuse. This is a 2 amp at 130 degrees, 250 volts. Same as this one. As you can see here, with zero continuity. This is open. Now we're gonna check our primary circuit without the fuse. We've got continuity. Sure. So now we have a new fuse soldered onto the secondary coil, sorry, primary coil. Now we're gonna check again for continuity. As you can see, it's continuous. We have nice continuity now on both sides of the fuse. So now I'm going to put everything back together and tape it up. As you can see, now I've put everything back together. Now we're going to reassemble the laminations, E and I laminations. Then we can connect it to a power source and test it. So now what we're going to do is we're gonna check the circuit board. We're gonna test the components here on the circuit board. First, we're gonna start with these small transistors and these diodes thing, because normally you don't get very good readings if you're testing components on the circuit board. So here on the table, I've got a diode and a capacitor. I'm going to show you how to test firstly how to test this diode. With your multimeter on the diode setting, you take your black lead, touch on the side where you have a line on the diode. You should get a reading that's between 400 to 800 millivolts, 500 millivolts. Then you swap your leads around. When you touch with the positive on the side where you have a stripe, you should get overload. You shouldn't get a reading. If you get a reading, it's an indication that your diode is faulty. No reading. This is a good diode. Now we're gonna go to this capacitor. This is rated 25 volts or 100 microfarads at 25 volts. On the same diode setting, with our negative lead on the shorter pin and the positive lead on the longer pin. This side with the stripe or shorter lead is your negative. You should not have continuity when you touch both these leads. As you can see, overload. So now we're going to test the capacitance of the capacitor. We're going to this setting here, microfarad. That's the capacitance setting. So this is rated 100 microfarads. We should get a reading close to 100 microfarads. 101 microfarads. Now let's check for voltage. As you can see, we've got a little bit of voltage. What I'm going to do now, I'm going to discharge it. This is how you discharge a capacitor. You can use a screwdriver or any material that's conductible. Our capacitor has been discharged. We should get a reading that's very, very close to zero. Zero. So when our multimeter is on the diode test, the multimeter sends a small voltage through the capacitor. Back to the diode test. I'm gonna hold it like this for a couple of seconds. This energizes our capacitor. So if we go back to the voltage setting, this should have a little bit of voltage, and as we keep our leads connected to the capacitor, it will discharge itself. You'll see the voltage going down. It will go down up until it reaches zero. Let me do a quick discharge. Zero. Now we're going to do the resistance check. Immediately after touching your two leads, you're going to get a number here. And that number is going to keep going up, going up, going up, going up, going up until it increases. It's going to increase up until it reaches overload. And that's going to show you that will be an indication that we have a good capacitor. So with your multimeter set at 2 mega ohms, or the highest resistance setting you've got on your multimeter, let me change it to 200 kilo ohms, because this is going to take a long time to get to overload. So now with our multimeter set at 200 kilo ohms, it's going to keep rising up until it says overload. That's an indication there. That's an indication that our capacitor is working fine. This is how you check if these small transistors, if they are PNP or NPN. The simplest way to illustrate this is to use diodes. On this drawing, as you can see, I use diodes, but this is not how it is wired inside. But this is going to help you to easily understand. So if it's a PNP, which means it's got 2 positives and 1 negative. On an NPN, it has got 2 negatives and 1 positive. As you all know, that negative lead goes on this side of the diode, and then the positive goes at the back of this arrow. So if it's a PNP, you're going to have a reading with your multimeter black lead on the base. You're going to get a reading on 2 positives. And then on the NPN, with your positive lead on the base, you are going to get a reading on 2. You're going to get a reading here on the first pin and on the second pin. This is our base, the one in the middle. The middle pin is our base. As you can see, no reading. This is not an NPN transistor. With the positive lead on the base, we get a reading on one lead and a reading on the other lead. This is an NPN transistor. And we should not have continuity between the emitter and the collector. If you've got continuity, then your transistor is bad, overload. Also, if you take your black lead, put it on the base, and your positive test lead on the other pins, you are not supposed to get a reading. Overload. This is a good working transistor. So now we'll put everything back together. We're going to assemble everything back together, and then we'll check if our charger is back to life. The battery charger has been assembled back together. Let's see if we manage to fix it. That is a good sign. But this battery charger, once the 2 jumper leads are connected to the battery, all the LED lights will shine bright. That's an indication that the battery is charging. As you can see, all the lights went on. So we managed to fix the battery charger. Thank you guys for watching.